Welcome back to our land of crazy. Today's lesson is about precipitation reactions. I'm going to go over precipitation reactions with you and how to write net ionic equations. So first of all, a precipitation reaction is basically a double replacement reaction. We're going to have two ionic compounds in solutions, which means the ions have dissociated, they're freely moving, and they're going to react to form two new compounds. You're going to have a precipitate as one of these compounds that will separate out of the solution. We'll just pretend that it's this one, and that then you will have the other product remain soluble and dissociated in the solution. So remember, if you see something is soluble, you will see a Q next to the formula. If it's insoluble, you will see an S next to it. Usually something that's soluble and insoluble, if something is insoluble, they'll also call it slightly soluble. It means the same thing. In terms of solubility rules, there was a whole reference table involved in Regents chemistry. In AP chemistry, all you need to know is that group 1 metals, ammonium, acetate, and nitrates are soluble in water. So anything that has an ammonium ion, an acetate ion, a nitrate ion, or anything containing a group 1 metal will dissolve. Everything else you can consider insoluble unless you're told otherwise. This is like a full solubility table. That's basically what you had in Regents chemistry. You do not need to memorize any of this. You don't need to memorize exceptions. So here's an example of a precipitation reaction or double replacement. So you can have a solution of barium nitrate react with a solution of potassium chromate. So in that original container, you have, when they start to interact, you're going to have barium ions, nitrate ions, potassium ions, and chromate ions. Eventually, the barium and chromate ions will bond together to form a solid precipitate, which would settle to the bottom of your container. The potassium and the nitrate ions, because that compound is soluble, those ions would remain suspended in the solution. So this is a nice sample question. Which of the following ions form compounds with lead-2 that are generally soluble in water? The answer there is going to be C, the nitrate ion, because all nitrate ions form compounds. Now, sodium ion, that's a group 1 metal, that's a soluble ion, but sodium is never going to form an ion with lead because they both have positive, they're not going to form a compound with lead because they're both positively charged. Now to go into different types of equations that you need to know how to interpret. So normally when you see a chemical equation, it will give you the overall reaction. You will have full formulas with the state symbols given to you. If not, you just have to determine what's soluble or not. You can then have the option to write an ionic equation. A full ionic equation just means that anything that is a soluble compound, you want to dissociate it. So the silver ions would dissociate from the nitrate, the sodium would dissociate from the chloride, and then for the products, the sodium would dissociate from the nitrate. But here, silver chloride is the precipitate. It does not dissociate. The particles stay together. Now, taking that former equation, you can form a net ionic equation, which means you're just going to cross out everything that appears exactly the same on both sides. So you're left with just the ions that react to form the precipitate. The ions that you've crossed out are called the spectator ions. They don't actually participate because they stay dissolved the whole time. So in this equation, we cross out the sodium ions and the nitrate ions on both sides. So you're left with the net ionic equation. When you're writing a net ionic equation, you need to remember to break up the following substances: all strong acids and strong bases, which this is a concept we address later in the year, so you're not going to really encounter it right now. But all salts that are soluble need to be broken up. You're not going to break up weak acids or weak bases. Again, something we'll cover later in the year. You're not going to break up any salts that are insoluble. You're not going to break up any non-electrolytes or weak electrolytes, which basically that would be covalent compounds. So if you see water as a product, for example, in a neutralization reaction, you're not going to split it apart. It stays as a molecule. Okay, for this example, you're given the full formula equation. It's already balanced, so we're going to write this out as a complete ionic equation. So I'm going to take this cobalt. It's a +2 charge because I know chlorines are each a -1. It's aqueous. And then I have 2 chloride ions here, so I'm going to swing that 2 as a coefficient, 2 chloride ions. And now I have 2 sodium hydroxides, both aqueous, 2 sodium ions, those are +1s. 2 hydroxide ions, those are each negative ones, aqueous. Now for my products, that is a precipitate. It stays together.
But it was at that time, at that simple time.
And then 2 sodium ions, aqueous, and 2 chloride ions, aqueous. And again, it's 2s because the coefficient gets distributed. Now, for the net ionic equation, I just have to cross out everything that appears exactly identical on both sides. So the 2 chlorides are aqueous on both sides. The 2 sodiums are aqueous on both sides. So the cobalt, the hydroxide, and then the cobalt-2 hydroxide will be part of the net ionic equation. So cobalt-2 ions plus 2 hydroxide ions will produce the cobalt-2 hydroxide precipitate. So that is my net ionic equation. My spectator ions are omitted. I'm just writing down what actually participated in the process. Here's one last example. So we're going to write out the full equation here. You have to get your formulas right and your balancing. And that is soluble because it has a nitrate ion present. That is soluble because, aqueous because it has potassium, which is a group 1. Lead-2 iodide. Precipitates because it doesn't fall into those other categories. Potassium nitrate is soluble because it has a group 1 ion. It also has potassium. Now this is not balanced, so go ahead and balance this equation. So when you balance this equation, you're going to need a 2 in front of the potassium iodide and then a 2 in front of the potassium nitrate. So it's pretty simple to balance. Now the complete ionic equation is not normally something you're going to be asked to write, but it helps you in writing the net ionic equation. So we'll go ahead and do that. My writing gets worse and worse. 2 potassium ions. And again, I do not dissociate my precipitate. Somebody has a really cool car. And now I cross out everything that remains exactly the same on both sides. The nitrates cancel out, those are spectators. The potassiums cancel out because those are spectators. Now I can go ahead and write my net ionic equation. Lead-2 ions, 2 iodide ions form the lead-2 iodide. Okay, so we'll do some practice with this in class, but this gives you just a simple introduction of how you need to write net ionic equations.